Okay, so this question is about a nuclear reactor. So nuclear fission occurs when a nucleus of uranium is split after absorbing a neutron. It is the process used in a nuclear reactor like the one shown in the diagram below. Okay, so we've got the typical nuclear reactor, and there's a couple of labels missing here. So the first question for 2 marks is complete the labeling of the diagram. So if these are the boron control rods, then the other rods in the nuclear reactor are of course the fuel rods. So they're made of uranium, or in some cases neptunium. And then this large block here is the graphite moderator. Okay, and this is what slows down the neutrons in order for the fission reaction to happen. Okay, and then if we move on, so we've got here a diagram below shows an uncontrolled chain reaction of the decay of uranium. So we start off with 1 neutron, which collides with a uranium nucleus. That then breaks up and it produces 2 neutrons, which can then go on to collide with a further 2 nuclei. They produce 4 and then 8. Okay, so this is the 4th generation. We start with 1 neutron and we end up with 8 neutrons. Okay, and the question says calculate the number of 5th generation neutrons. So basically each time it doubles. Okay, so we go from 1 to 2 to 4 to 8. The next stage would be 16 neutrons. Okay, so we get double the previous generation. Explain how the number of neutrons in your answer above would change if the control rods are lowered further into the reactor. Okay, so the control rods, they absorb neutrons and prevent them from colliding with nuclei, and therefore the number of neutrons would decrease. Okay, so control rods absorb neutrons and prevent them from causing fission or splitting. So ultimately that would reduce the number of neutrons. Okay, and then state the danger of an uncontrolled chain reaction in a nuclear reactor. Okay, so the dangers are that we could have meltdown. It can also lead to explosions, which also produces radioactive contamination of the environment. Okay,